So we talked about this a bit in class, but I would like to talk about it in more detail. So the Cartesian equation of a plane in space. Well, first of all, if we think about a line in 2D, here's my line. It has direction vector m, so that's like my slope, and it has only one perpendicular vector. So I know that this vector is going to be perpendicular to the direction of my line. So we know that n dot m will be equal to 0. Well, m is also my known point to any point on the line. So vector m is some multiple of my POP vector. So POP is going to be x minus x naught, y minus y naught. So if I substitute this in for m, my n vector is AB dot x minus x naught, y minus y naught, and that's going to be equal to 0 because I know they'll be perpendicular. So it doesn't matter what this scalar is, how many times I go the direction, however long that vector is, the dot product will be 0. So that's why I can ignore that. So if I expand this, I'm going to get ax minus ax naught plus by, so I'm going to put the by first, minus by naught. So I'm going to put all those minuses together. So that's ax naught plus by naught, and that equals 0. Well, notice this is really the same as saying ax plus by plus some constant equals 0, or the equation of a line in standard form. But thinking about 3D, if I have a line in 3D space, there's not just one normal. There's infinitely many normals. So I can't do this for a line in 3D, but for a plane, well, no matter which two vectors I pick on this plane, the normal to those two vectors is always going to be perpendicular to every vector in the plane. So I can do something similar. I can say that for a given point on the plane, any vector on the plane connects my xyz to that given point, and my normal will be perpendicular to it. So if my normal is ABC, and the point I know is x0, y0, z0, then the vector from this point to any point on the plane will be perpendicular to n. That means the dot product is 0, so I can write out x minus x naught, y minus y naught, z minus z naught, dotted with ABC equals 0. This leads me to ax plus by plus cz minus ax naught plus by naught plus c z naught equals 0. So in 3D space, if I have ax plus by plus cz plus some constant d, that gives me the equation of a plane.